Good morning, students. I hope you all had a really great weekend and hopefully you feel ready to move on to another week of online learning. So now this is week 5, April 20 to April 24. And just to quickly show you one more time how to access all of your materials, right now I'm looking at one of the science classes, and something that I want to remind you all of is many of you are asking me like how many missing assignments you have. One way to find out is if you click on grades right here for science class, and it's going to open up your grade book, and the assignments that are missing or incomplete, it's gonna have this symbol right here marked as incomplete. So as you scroll through, it should have your scores, and then it should tell you which ones are incomplete. So if you see this, that means that those are the assignments you need to make up. So say that you realize like, oh no, I didn't do my states of matter test, then you can click on that assignment title and it'll take you straight to the assignment right over here. Okay, now going back to our class materials over here, now that it's week 5, we're going to be using this blue folder. It says online learning week 5. I'm not going to click it yet, I'll click it in a little bit. And over here I linked the weekly schedule overview. So this slide right here shows you everything that we'll do every day of this week, Monday through Friday. So if you're curious to know what we're learning this week or what we're going to do this week, you can look ahead for the week. And then down here, red, orange, yellow, and green folders for the previous weeks. So last week was week 4. So before I move on to week 5, I do have to go over some of the assignments from last week. So last week on Friday, you were supposed to look at the study guide and take the test that was due yesterday. So in this video, I'm gonna go over this test, and I'm gonna go over answers to this test. And that's very important because some of you might not like the score that you got from last week's test. So if you are someone who wants to retake their test for a higher score, you're gonna get to do that today for your assignment. So if you keep watching this video, I'm going to go over answers to this test, and then you can use that to help you do much better on the retake. So one more time, if you watch the entire video, I will go over answers to the test, and you can use that to take the retake. It will have the same questions. Okay? Now, for Friday's test, it had said to open up the study guide because this test requires a password. So if you follow directions, you should have opened the study guide, and you were supposed to study all of these words. And then if you scroll all the way down, it says password for the test. I'm not going to show you right now because you should do this on your own, but if you keep scrolling all the way down, it has the password for the test that you were supposed to take. Okay, so again, I'm going to go over the answers to this test at the end of this video, so just keep watching. Alright, so now that it's week 5, you're going to go to the online learning week 5 folder, and you're going to click on online learning week 5 slides. And when you click this, the slides are going to pop up right over here. So I'll press present and go over this week's slides. So this is the overview, and since today is Monday, we're going to go over Monday's assignment. That's why I have a red box here. So what are we going to do? You're going to check in with me and then watch this video that you're watching right now. And what will you turn in on Schoology? You're going to comment on the discussion post and retake the test if you need to. If you got a score that you're proud of, you don't have to retake it. Okay, pressing next. Again, if you're someone who fell behind, I messaged you with all the incomplete assignments you have. You can check week 1, week 2, week 3, and week 4 to see what you're missing. And if you're ready to move on, you can click right here. And now it says Monday's lesson, April 20th. Our do now. you're going to review the types of thermal energy transfer test questions and address any misunderstandings by watching this video. And you will demonstrate your understanding of thermal energy transfer by conduction, convection, and radiation by replying to the discussion question today. Alright, so these are the two things that you have to turn in. You can find it on Schoology. It looks like this. And then these are the two things that you're going to do right now. So first, you're going to check in with me. So it says directions, click on this link to fill out a form so that I can check in with you and see how you are doing. So you will press this link. If you're watching this video, it means you already did this step, but just in case you didn't. And you're gonna fill in your first and last name, and you can fill in your answers. I just want to know how you're doing and use this information for the remaining 9 weeks that we have of learning online. So please fill out this form honestly the best that you can. Okay, and when you're ready to go back, now we're gonna go to number 2, which is to watch the review video. That's the video you're watching right now. So now let's keep going. Alright, so we're going to review some of the things that we learned from last week. So quickly, I'll go over these slides, and then at the end, I'll go over the answers to the test. So again, we learned that heat is the thermal energy that flows from one substance to another due to a difference in temperature. So heat is not thermal energy, it's thermal energy that transfers. And how does thermal energy transfer? It goes from warm areas to cool areas. So for example, thermal energy transfers from this cup to the hand because there's a difference in the temperature. This cup is much higher in temperature than the hand. So since the temperature is different, thermal energy will go from the cup to your hand. Now when thermal energy has transferred, what's gonna happen? Well, then the temperature is gonna change. So the temperature of the coffee is gonna go down since it gave some of its thermal energy to your hand, and the temperature of your hand is gonna go up since it gained thermal energy from the coffee. And we learned that there are 3 ways that thermal energy can transfer. There's 3 different ways: conduction, convection, and radiation. And you saw this picture in your test. You should have memorized these 3 things. So again, this is conduction. The particles in the hot water are bumping into the particles in the aluminum because they're in direct contact. The particles in the aluminum are bumping into the particles in the ice cube, so there's direct contact, and that's what's allowing the thermal energy to transfer from the hot water to the aluminum and then to the ice cube. So let's see if there's a bigger puddle. And there's more water right there because the ice cube is changing states. So this demonstration video, hopefully you watched it last week, it's showing us conduction. So conduction is the transfer of thermal energy through direct contact. That's our key word, as these particles collide and bump into each other. So let me show you. As the fast-moving particles in the hot water collide into the particles in the aluminum, and they transfer thermal energy. And when the particles in the aluminum bump into the particles in the ice, they transfer thermal energy. So this is conduction because the particles are colliding. They're bumping into each other. So when the particles that are moving fast bump into the slower ones, they're giving some of their energy to that particle. That's why they all start to move faster. And some more examples of conduction. For example, in this, the spoon gets hot because it's touching the hot coffee. There's direct contact. So the particles of the coffee will hit the particles in the spoon and transfer some thermal energy. Alright, so when I take this cardboard off, we're going to see what happens to the water. So as soon as I took it off, you saw that the red hot water rose to the top and the cold blue water sank to the ground, to the bottom. And now the temperature between the cold and the hot is starting to become more equal, because thermal energy from the hot water, it mixed or it transferred to the cold water as the hot water rose up and the cold water sank down. And now you know that they mixed because the color changed. Blue and red made purple, so you know that the color has changed because thermal energy has transferred. So this video showed you convection. Convection is the transfer of thermal energy by the movement of fluids. And what are fluids? Liquids are fluids, and so are gases. So the air particles are in the gas state, so that's also considered a fluid. And how do fluids move? Warmer fluids always rise up, and the cooler fluid always sinks down. And that's why the colors mixed, because the hot water, red one, rose to the top, and the blue cold water sank to the bottom. And when that happened, thermal energy transferred between those two waters. So right now I'm going to go ahead and put the hot water beaker on top of my colder beaker, and we'll see what happens. Okay, so now I have my hot water. I'm going to flip it upside down very, very carefully. Alright, and I'm going to put this exactly on top of my other mason jar. And then I take the cardboard paper off. We're going to see what happens. Alright, so now if we wait and see, we're gonna observe how nothing is really changing. And the reason why is because, well, before we get to that, if you look at what's going on right here, the hot red water is staying on top and the cold blue water is staying on the bottom. And how is that possible? Why aren't they mixing? Well, we know that hot fluids, like hot water, rises to the top and they stay near the top because they are less dense. They don't weigh around the same, they don't weigh as much because the particles are all spreading out. They're moving very fast and spreading out, so they are less dense, so they stay at the top. And the cold fluids, the cooler fluids like cold water, sinks to the bottom because when something's cold, the particles move slower and they are more dense, so they stay near the bottom. All right, so in the second part of the demonstration, again, it showed you how these two waters didn't mix because the red hot water stays at the top and the blue cold water stays at the bottom. I'm just going to go over one more video from convection in the next slide. So first, I'm going to put my ice cube. Not this one. Now let's see what happens when I put my water bottle in the hot water beaker. Alright, so as soon as I put the water bottle in the hot water beaker, the balloon inflated and it rose up. And why did that happen? Well, the particles in the hot water have a lot of thermal energy. So they're going to transfer thermal energy to the air particles inside of the water bottle. And as the air particles start to gain thermal energy, remember, they get hotter and hotter, and we learned that hot fluids like gases and liquids will rise to the top. So all of the air particles in the balloon, as they gain thermal energy, they get hotter and they start to rise to the top and fill up the balloon. So our balloon inflated. Now when I take it out of the hot water and put it in my cold water, let's see what happens. So in the cold water, the air particles are going to start to lose thermal energy to the cold water. And we learned that cold fluids are going to sink to the bottom. They will float to the bottom. So now you see that the balloon is starting to deflate little by little. It's losing thermal energy, and colder fluids sink down, so the balloon will no longer stay inflated. So if you wait a little longer and wait for the thermal energy to transfer out of the water bottle and into the cold water, you should see that the balloon starts to deflate. There we go. So the balloon is deflating because it's losing thermal energy. So then the particles in the balloon are going to sink to the bottom of the water bottle since cooler fluids sink down. And one more time. Cooler fluids sink to the bottom, so the cold air particles started to go to the bottom of the water bottle. And when I put it back into a hot water bottle, the balloon starts to inflate again because the hot air particles will start to rise to the top. Okay, and then another example of convection is in this video. As the fire heats up the water particles are going to rise up since they have a lot of thermal energy and kinetic energy. And then the colder water particles are going to sink down. And as that happens, thermal energy will continue to transfer. And soon enough, the whole pot of water will turn hot. And even hot air balloons, that's how they inflate to the top. So there's a fire right here, and all the air particles near the fire are going to rise to the top of the balloon and bring the balloon up. And then the colder air particles are going to sink down and get heated, and it's going to keep cycling. That's how a hot air balloon works. So here I have a heat lamp. This lamp turns very, very hot, and I'm going to turn it on, and here I have black paper with an ice cube. Alright, so when I turn it on, I feel heat on my hand. Even though I'm not touching the light bulb, I feel heat on my hand because electromagnetic waves are bringing the thermal energy to my hand. And if I place it on my ice cube long enough, you should be able to observe and see what happens to the ice cube. Even though it's not touching the ice cube directly, you should see that thermal energy is still going to transfer to the ice cube. So again, thermal energy is transferring from our heat lamp to the ice cube without touching it because this is radiation. It's transferring through electromagnetic waves. And I'm going to go ahead and turn it off and see if the ice cube melted a little bit. Alright, so if you look here, there is a little puddle of water, so you can see that the ice cube gained thermal energy from the heat lamp through radiation, the electromagnetic waves. Okay, and then the key information for radiation is that it does not involve matter. It does not involve direct contact. It's not like conduction. Radiation, thermal energy can transfer through space because of electromagnetic waves. So another example is when you feel fire, the heat from the fire, you're not touching the fire, but electromagnetic waves from the fire carry thermal energy to your hand. And even a microwave, that's how it heats up your food. So here's a summary page. These are the key words. Conduction is direct contact. Convection is the movement of fluids. Hot fluids rise up. Cold fluids sink down. And radiation is through space by electromagnetic waves. So keep trying to study this picture because this is a good example of all three types of thermal energy transfer. Alright, so now that you've watched the review video, I'm gonna first go over the test questions, and then you'll get to go and comment on the discussion board. And then after you comment on the discussion board, you get to retake the thermal energy transfer test. But before you retake it, make sure that you study the test study guide because I put a new password for the retake. So there's a new password for your retake and it's written on the test study guide. That's my way of checking and making sure that you study your study guide first. All right, so now I'm gonna go over the test questions and hopefully this will help you do better on the retake. So when you click on the retake, it's gonna ask you for a password when you try to start the new attempt. So I'm gonna go ahead and press start new attempt. And I'm not gonna go over everything, but I'm gonna go over 5 questions that students had trouble with. So I saw a lot of kids got question number 3 incorrect. So let me go over that one. It says 2 solid blocks are heated to the temperature shown here. Then they are placed next to each other so that they're in direct contact. Which diagram shows the direction heat will flow? And remember, thermal energy will transfer when there's a temperature difference. So these 2 blocks, they're both 0 degrees. They are the same temperature. So thermal energy will actually not transfer. Heat will not flow between the 2 blocks because they are the same temperature. So when you take your test, find the answer that says no heat flow. 0 degrees and 0 degrees are the same. Heat will not flow because they're the same. And then I also saw people get question 6 wrong, so let me go over this one. 2 solid blocks are heated to different temperatures. Block 1 is 13 degrees, block 2 is 10 degrees. Then they're placed next to each other so that they're in direct contact. Heat begins to flow between the blocks. Later, the temperature of each block is measured again. Which pair of temperatures is possible in this situation? So block 13 or block 1 is 13 degrees, block 2 is 10 degrees. So block 1 is hotter. It's going to give some of its thermal energy to block 2. So if block 1 gives some of its energy, then block 1 is going to decrease in temperature. And block 2 is going to gain some thermal energy, so block 2 is going to increase in temperature. So you have to find the one that shows that block 1 went down in temperature, but block 2 went up. So it can't be this one because remember block 2 has to go up in temperature. It can't be this one because again block 2 has to go up in temperature. So it has to be this answer. Because block 1, it's going to lose thermal energy, so it's going to go down in temperature, while block 2 goes up in temperature just a little bit. And then also question 7, same type of question. Block 1 is 167 degrees, block 2 is 197. So since this one has a higher temperature, it's hotter, block 2 is going to give some of its thermal energy to block 1. Thermal energy is going to go from here to here. That means block 1 needs to go up in temperature and block 2 is going to go down in temperature. So we have to find the one that's in between. Now, block 2 is not going to give away so much thermal energy that it becomes colder than block 1. They're going to try to reach around the same temperature. So block 2, the best answer would be that it has to be in between these 2 numbers. So if you look here, this one's not possible because why would block 2 give so much thermal energy to block 1 that it becomes colder than block 1? That's not going to happen. And over here we said block 2 has to decrease, but this one shows that it increased. So that's not correct either. And for this one, again, block 1 is going to have to increase since it's gaining thermal energy from block 2, but this one shows that it didn't change, so that can't be correct. Now this is the correct answer because block 2, since it gave away thermal energy, it decreased in temperature even if it's just by 1 degree. And block 1 gained thermal energy, so it increased in temperature. So this is your correct answer. Now let's go over 2 more. Number 13. Number 13 says an egg cooks on a hot frying pan. So the egg is touching the hot frying pan. It's on top of the frying pan. So thermal energy is transferring from which one's hotter? Remember, it always goes from hot to cold. Thermal energy transfer from the frying pan because the frying pan is hot and it transfers to the egg. That's how the egg cooks. And how did that happen? Well, they're touching. The egg is touching the frying pan. There's direct contact, so it's conduction. This type of thermal energy transfer happens because of direct contact. And then last one, number 16. The room gets warmer due to the heater. The warmer air near the heater rises. Remember, hot air rises, and the cooler air sinks until all the air in the room is warm. So thermal energy transfers between remember, it's always warm to cold, so between the warmer air and the cooler air through, well, this is the movement of fluids. So that's going to be convection. And why did this happen? Because hotter fluids rise up and cooler fluids sink down. Okay, so those were the 5 questions I saw a lot of people needed help on. So I gave you the answers to number 3, 6, 7, 13, and 16. So when you retake your test today, if you want to, you should get those questions correct because you watched this whole video. So good job watching the entire video. All right. Now I'm gonna go ahead and end the video over here, but just a reminder that once you end this video, your job is to go to the blue folder, which is week 5, and make sure that you check in with me, make sure you comment on the discussion, and retake your test. Now let me just show you the discussion really quickly. So the discussion says, watch the review video, that's the video you're watching, and comment with your response to the following prompt. Provide your own example of conduction, convection, or radiation. So what you can do is you can copy this sentence starter, and then you can paste it over here, and you can fill in the blanks with your own example. So my example was, when I lay my head on my pillow, thermal energy transfers from my warm head to my colder pillow through conduction. I know this is conduction because my head is directly touching the colder pillow. So I want you to think of your own example. It can be conduction, convection, or radiation, but you can erase the blank and fill in your own answers, and then go ahead and press post. Alright, thank you for watching the entire video. I will talk to you in tomorrow's video, and also I hope that I can see you on Thursday through our video conference. Alright, please get your work done today. Have a good rest of your day.